All right, so here's another one that you're not going to need to take notes on. Just make sure you understand what we're doing. I have little doubt that Jeffco is smart. So we're still dealing with the claim that Jefferson College students on average are smarter than the general population. So this time we're going to look at it a slightly different way. We're going to say, what if they're not? What if they are just average? What if the average IQ for Jefferson College students is 100, which is the general population, and the standard deviation is 15? Well, then what I want to do this time is look at if this is true, right? So we're assuming the opposite of the thing we're trying to show. We're trying to show they're smarter than average. We're going to assume that they're just average. And then we're going to say, if they are just average, what's the probability that we would get the results that we get from our study? Now, remember this central limit theorem says that if we take a sample from a population, the averages of those samples are normally distributed. The mean is going to be the mean of the population, and the standard deviation of the distribution of sample means is the standard deviation of the population divided by the square root of the sample size. Okay, if you want to, you can go back and watch the video on that for some clarification, but I don't think you'll need it. We're not going to actually run the numbers here. I've already done them for you. So what happens if Jefferson College is average? The mean is 100 and the standard deviation is 15. Suppose we took a person from Jefferson College at random. What is the probability that that one person would have an IQ of greater than 103? Okay, so what would be the probability? We have 103 here. What would be the probability they would fall that far above the average? And the probability that they would is 42%. Okay, so put this into the hypothesis testing realm. We're assuming, we want to show Jefferson College is smarter than average. So we're going to assume they're not. We're going to say, nope, that's not true. And then we're going to pick a person and they've got an IQ of 103. How likely is that to happen if Jefferson College is just average? Well, it's extremely likely to happen. 42% of the time, a person chosen at random from a normal population would have an IQ that far above the mean. So that is not convincing, the fact that I found one person that had an IQ that was that far above average. So what we're going to do is we're going to take a sample. Let's take a sample of 25 students. What's the probability that a sample of 25 students would have an average IQ of 103, given that the population they came from was average, with an average IQ of 100? Well, still, that's not terribly convincing. If this is true, if we have an average of 100 and a standard deviation of 15, then a sample of 25 is going to have an average over 103 about 16% of the time. So not terribly convincing. And again, what changed here was that if the sample size is 25, then our standard deviation is going to be 15. That has nothing to do with this picture here. Just 15 standard deviation of the population divided by the square root of 25, which is 3. So here, to calculate the 42%, we're using the standard deviation of the sample mean distribution of 15, because the sample size was 1. Here, we're using a standard deviation of 3, which decreases the likelihood we'd be that far above the mean. If we take an even larger sample size, okay, we take the sample size of 100, well, that's going to make the central limit theorem says that the distribution of sample means now is going to have a standard deviation of 15 divided by the square root of 100, which is 1.5. So now we're actually 2 standard deviations above the mean, right? If the standard deviation of the sample distribution is 1.5, then 103 is 2 standard deviations above the mean. Here, the standard deviation was 3, so we were a whole standard deviation above the mean. Here, we were not even a standard deviation above the mean. So what's the probability that if we took a sample of 100 people, that the average IQ for that sample would be 2 standard deviations above the mean? That's only going to happen about 2.3% of the time. So again, we're assuming that Jeffco is normal. We have an average of 100. How likely is it that a person chosen at random would have an IQ of 103? 42% of the time. That's not going to convince me that Jeffco is smart. How often will it happen if I choose 25 people at random that their average IQ would be 103? That's going to happen 16% of the time. That still doesn't impress me. That's not going to convince me that Jefferson College is smart. Here, if I take a sample of 100 and I find their average IQ is 103, that's only going to happen about 2.3% of the time. So if you're trying to convince me that the average IQ for Jefferson College is greater than 100, these two aren't going to help, but this one is. You choose 100, you show me the average is 103. That doesn't happen very often, so it's unlikely that it would happen if this was true. So this is fairly convincing argument or convincing evidence that Jeffco is smarter than average. All right, try to get your head around the idea that we're talking about here. We're looking at how likely we'd be to get a result this far from the mean if this was actually the case. We'll put this together, I think, in the next video. I'm not sure. It might be another one after that. See you soon.